talking about Synopsys and our RISC-V solutions here. More than just point tools, we're talking about a range of solutions for RISC-V. So, beautiful slide here. Thank you to our marketing department for this. One of the things that we have here at Synopsys is this range, this portfolio of products that we're building into solutions. On the left there, we see early architecture exploration and software development tools, things like ASIP Designer and Empiric's PDK, Platform Architect at the SoC level, Virtualizer. Moving on, processor verification. We've got formal tools. We've got tools for that are simulation-based and require a model. The Empiric's FPM, fast processor model for RISC-V, is the key to that technology. And then, as we move on in verification, we want to use hardware platforms, use emulation and FPGA prototyping. Those platforms also get used for software development, and that's where the HAPS and ZeBu platforms from Synopsys come in for test generation on the hardware-assisted platforms, hardware-software co-verification, early software development. And then, because we're Synopsys, we also have IP, so it's a full solution. We've got the tool side to help you with your development project, but also the ARC-V processors, the RISC-V processor IP. But as Synopsys, we also have other IP that can help you complete the rest of the SoC. So let's go into a bit more detail on all of these, starting with the architecture exploration tools, moving from processor to SoC. The first one here is ASIP Designer. ASIP Designer is a language-based tool where you describe your processor model, and then you can generate the RTL for implementation, but you can also generate the SDK, the software development kit, providing your tool chain. So with ASIP Designer, this lets you look at both the hardware and software implementations. The nice thing here is a language-based description of the tool is that you've got a lot of flexibility in the features that you design here. And there are RISC-V examples, RISC-V templates for building a full CPU or building a RISC-V-based accelerator for your SoC. The complementary approach to this language based approach with ASIP Designer is Empiric's PDK, the Processor Development Kit. This is based on the Empiric's FPM model, and what this does is to allow developers to add in some features to the model, execute their software on that, and understand the impact that these custom instructions are going to have on the software execution. So Empiric's PDK is going to help people with the development of the custom instructions. So these are both at the processor level. Platform Architect is industry-leading tool on SoC architecture exploration for performance and power analysis. And there are specific features that have been added to Platform Architect to support RISC-V. So again, it's first part of our portfolio for supporting RISC-V. The second piece of the solution is verification. And verification includes both formal and dynamic verification. On the formal side, the Synopsys formal tools include RISC-V assertion IP, the AIP, that's up there, so that you can do unit-based verification as a complementary approach to the dynamic verification. On the dynamic verification side, Empiric's DV is a co-simulation and checking verification environment. So what this allows is the user to do a step and compare in verification. And then on the test generation side, feeding into Empiric's DV, we have Sting for test generation, a constrained random test generator, and also the Empiric's TS test suites. These are test suites for architecture validation and especially focused on complex configurable extensions in RISC-V, such as vector, MMU, and PMP. And these are going to execute both on RTL simulation platforms, VCS in particular here, as well as on the hardware-assisted platforms, ZeBu and HAPS. I've mentioned the Empirus FPM as being at the heart of these verification tools. So the Empirus FPM, this is a technology that's evolved over the last 18 years or so. It supports not just RISC-V, but more than 15 different ISAs. The approach, this API-based approach here, provides a very high performance, fully functional reference model. On the RISC-V side, the base model supports the RISC-V specification in full. It's also fully user configurable to whichever extensions you want, but also which version of each extension you want to use. Because as users, you're going to start your implementation on a specific version of an extension and go from there. The user extensions for custom features, custom instructions, CSRs, are actually in a separate file so that if you're adding those custom instructions, it's not going to perturb the base model, which gets used in every one of our RISC-V models. And doing this approach, this means that RISC-V base model has been used by over 150 different companies, organizations, and universities, and has been used to tape out, I think, more than 50 SoCs with RISC-V processors in them. So we take that Empirus FPM, that reference model now, and it can be used, as I mentioned, in the verification flow with the Empirus DV, and also with Virtualizer in a virtual prototyping environment for software development. And the key thing here is that using the same model for both hardware verification and software development enables a significant reduction in SoC bring-up time, because all your development has been done using the same reference. So when you actually get to hardware, things come together quickly. Best example of this is a customer that was building a AI SoC, complex device with over 100 different processors. They did their development using the Empirus FPM on both sides of it, hardware and software. That complex AI SoC came up in the lab in a couple of days, getting software running. So that's a significant reduction from the months that they had expected there. A little bit more detail on Empirus DV, this RISC-V processor verification solution. So this is actually a family of products. The Empirus FPM is the reference model. There's a lockstep continuous compare methodology. This methodology, this lockstep compare, performs the scoreboarding and checking and configuration. And one of the key things here is that it supports asynchronous events. So things like interrupts and multi-core and debug mode, things like that are very difficult to do using other verification methodologies. It also supports weak or strong memory consistency in the RISC-V specification, and it provides functional coverage. So we have pre-existing automatically generated functional coverage modules that are part of the Empirus DV family of products. On the test generation side, Sting is the industry-leading test generator. It generates constrained random, directed, graph-based approaches. It also supports the full RISC-V specification, but can also handle custom extensions and multi-heart, and again, memory coherence and concurrency. And with Sting, you're able to run using RTL simulation, but also running on the hardware-assisted platforms. And in fact, in the Synopsys booth, there's a demo of Sting running on a ZeBu hardware emulator. So architecture exploration, design verification, software development. Software development, Virtualizer is the key tool for that. It is the industry standard for virtual prototyping. What virtual prototypes do is allow you to shift left your software development. So it helps with not just on the schedule side of things, but also with multi-core, multi-SoC platforms. It helps with software testing. These things are easy to integrate. These virtual prototypes are easy to integrate into a CI/CD environment so that you can automate your testing. That's pretty standard now on the software side. The nice thing about virtual prototypes compared to, say, FPGA prototypes or other hardware is that they're virtual, so that if you have a distributed development team, which most companies have at this point in time, it's pretty easy for everybody to be on the same virtual prototype doing development. It also helps enable the full chain, the full supply chain for that. And it can also help on the hardware verification side, and it works with HAPS and ZeBu in a hybrid mode. And so that's the last piece on the tool side, is these hardware platforms. HAPS, the FPGA prototyping solution, ZeBu, the hardware emulation solution. These are tools that have matured, they've been around, and we've got customers using these for RISC-V hardware verification and software development. Architecture exploration, design verification, software development, but also the IP. So Synopsys has been in the IP business for quite a while, in the processor IP business for quite some time. The original ARC processor IP goes back more than 25 years now. Over the last few years, we've evolved that so that it's supporting the RISC-V instruction set architecture. And now there are these 3 series of processor IP families: the RMX controller series, the RHX real-time computing series, and the RPX high-performance series. The nice thing about these as well is that you can get versions of these that have been qualified for automotive with ISO 26262, functional safety, and also for cybersecurity, ISO 21434. So this is a broad portfolio of RISC-V IP coming from a supplier that actually knows how to deliver and has been delivering for a couple of decades processor IP. So Synopsys, what are we doing here? We're providing RISC-V solutions. We're providing solutions on the tool side, solutions on the IP side. We're uniquely positioned to support the expanding RISC-V processor ecosystem. We've got the ARC-V processor IP. We've got these EDA tools and reference methodologies for successful implementations of RISC-V processors. We've got expert design services because we've been doing this for a while. EDA tools and SoC development, but also the RISC-V experience. And this is silicon-proven success, in particular with RISC-V, because, as I mentioned before, we have had more than 50 SoC tapeouts with RISC-V processors that have been enabled by the Synopsys tools. You can get more information at the Synopsys RISC-V website, synopsys.com/RISC-V. Thank you very much. Happy to answer questions.